Hey there, welcome to a video discussing section 3.1 on identifying pairs of lines and angles. So actually, we're going to be doing three sections today like we've done in the past few class meetings. And our plan is to cover three sections like we usually do. Today's focus is going to be on parallel lines. So you can see 3.2 talks about using parallel lines, something called transversals. 3.3 is talking about proving lines are parallel. So one thing that you guys need to know about parallel lines is that the two lines that don't touch, right? Very important. The lines are parallel. They never touch. Also, they're on the same plane. And let me actually turn the video on to myself. Sorry, I got my hat on backwards. I'm actually at a local Starbucks here in San Diego. We just made it back from Arizona last night. I've got a good time. Got some dinner, a little Italy in the San Diego is really nice. And we're staying in some sort of a cheaper motel as we fly back today. We will be, I'll be back home finally in Sacramento. But think of these as two parallel lines, right? That would not be okay. So I'm not sure if you can tell what I'm doing, but I have like my black pen pointing towards the screen, my blue pen pointing up. These won't touch also, but these are not parallel. They're not on the same plane. These will be on the same plane. When you have a situation like this here, we call that skew. I'm going to talk about skew in a little bit. Not this video, then maybe another video. But they have to be on the same plane to be parallel. So that's one thing that's important. And then number three, same slope. Now, you probably learned about slope in Algebra 1. And slope is such a big deal. In fact, actually, I taught AP Calculus AB. And we talk about slope all the time, believe it or not. It's actually the basis for the first semester of college level calculus, first semester, first quarter. So yeah, slope is a big deal. So always have the same slope, because if you think about it, slope is rise over run, right? Change in y over change in x. So if you have a line that looks like this, you're going to want the other lines to follow the same rise and run so that they never touch. So they'll always have the same slope. Another thing you need to remember is y equals mx plus b. That's a very important part of mathematics. That's a linear equation. And m's always going to be the slope. So if you look at number one, for the graph, will these be parallel? Well, what you could do is isolate y in each case. So move the 6x over from right to left, sorry, left to right. A little tired right now. It's 6:05 in the morning. Divide by 2. Oh yeah, I'm at a Starbucks because yeah, I don't want to wake up my family. They're still sleeping. So, and then y equals 3x plus 4. So you can see the slope here is 3. The slope here is -3. So the answer is no. That's because they are going to touch. In fact, actually, let's go to Desmos. Desmos is actually going to be one of your best friends when dealing with graphs. Looking at baseball stats, sorry about that. Yeah, so if I do 6x plus 2y, and that's the beauty about Desmos, that you could actually type in the equations the way you see them. Or if I do y equals -3x plus 5, you get the same line, right? They're identical. I'm gonna go and clear my screen so you can see a little better, right? Those are the same lines. But if I were to type in the other equation, which I already forgot what it is, 3x plus 4, there we go. Y equals 3x plus 4. Yeah, those are not parallel, obviously. Those are touching, in fact, actually at that point right there. If I did this, now they're parallel because they have the same slope. They're rising and running the same way, right? See how this goes down 3, right 1, right down 3, right 1. Remember, slope is change in y or change in x. Or you could take a couple points. Slope is also defined as this, y2 minus y1 over x2 minus x1. Again, y2 minus y1 is the difference in y. That's a change in y. And this little triangle here, if you don't know, it's called delta in the Greek alphabet. Delta means change. And then, of course, change in x or change in y, or x2 minus x1. So you can always pick random points on the line, 2 random points on a line, take the difference in y's, difference in x's, and then divide the change in y by change in x. That will be your slope. And the red line does the same thing. Goes down 3, right 1. So that's what makes it parallel. But for the warm-up, we didn't have that. Excuse me. I don't know these word plexers. Let's cross it off. I'm not going to do that. Okay. So again, parallel lines on the same plane, they never touch. And same slope. Oh, there you go. Skew. I was a mind reader. I didn't know the notes were going to talk about skew. So skew, they also don't touch, but they're not on the same plane. So we could say potentially M and K are skew. Yeah, that would make sense. I guess these may not necessarily touch, but they're not on the same plane. But M and N are parallel because they're on the same plane. Also, planes T and U, planes could be parallel if the planes never touch. That's also possible. Let's look at 3.1.1. Think of each segment of the figure as part of a line. Which line or plane in the figure appears to fit the description? So lines parallel to CD. So CD is right here and contains a point A. Definitely line AB. Definitely line AB is parallel to that because you want to be parallel, right? They said so. Now, line that's skewed to CD and contains A, I'd say AH. Because AH is not going to touch CD, but they're not on the same plane. So remember, same plane has to be on a 2-dimensional figure. Going back again. See, that's a plane right there. Excuse me. That's a plane. So that's what AB and CD will be parallel. But AH and CD are not on the same plane. A line perpendicular to CD and contain point A. So again, here's point CD, and you want to be perpendicular to CD and contain point A. I'll go AD. I'll go AD right there. You see the right angle right here. Finally, a plane parallel to plane EFG. So EFG is right here. You only need to state 3 points to have a plane, but really the plane is all this right here. Also contains point H, just so you know. But a plane parallel to that plane and contains point A, that's going to be plane CDA. But if you said CDAB, that's fine. Or if you said DAB, that's fine. If you said BAD or BCD, that's fine. You just need to at least state at least 3 points. So when specifying a plane, just need to list 3 points. So, but that's those planes are parallel because they'll never touch. Parallel postulate, there's exactly one line through point P, parallel line L. Yeah, so if you have a random line, like this right here, I'll call this line L. And if you have random points, call P. There's only one way I could draw a line through P that would be parallel to L. And say I call this like line M. There's no other way. If I draw other lines through point P, they're going to touch L at various places. Now, what if you decide to go three-dimensional and maybe have a line coming out of my screen and behind my screen towards this bathroom here at Starbucks? That's going to be skew then, right? Remember, they have to be on the same plane to be parallel. Perpendicular. Same thing. If you have a random line, called line L, a random point called P, and you want to draw a line through P so that's perpendicular to L, it's only going to happen once. That's it. No other way. So that's what we got there. Okay, here we got a swing set. And they're asked to name a pair of parallel lines, name a pair of perpendicular lines. Is DH perpendicular to LM? Explain. Okay, well, you could say CN is parallel to HI. And we use a symbol here just so you know to denote parallel. So we do that for parallel. Think about like if you're parallel parking, right? You're going to be, you don't want to touch the curb, right? You want your car to be, you know, in line with the curb. Perpendicular, like if you think of a street intersection, usually those are perpendicular. That's the symbol used for perpendicular. There are more parallel lines, if you wanted to say so. You could say AC and LN. I said lines, I'm using the symbol for lines right above each curved letters there. You can also say BC and MN. See, those are parallel. You know, again, we had CN, right? You can see, say CN was parallel to like AB or LM or JK. Or you could also say HD is parallel to IE. You know, this is the cable or the chain that connects the actually seat of the swing to the top that you see there. Or HD is parallel to FJ or GK, or you could say any of those lines like GK is parallel to FJ. There's so many possibilities here. Perpendicular lines is when they form a right angle. I probably would say like DH is perpendicular to CN. And by the way, you don't have to call it CN if you don't want to. You can call it DE, EF, FG. Just pick any 2 points on the line. But I would say those are perpendicular. You could also say IE or FJ is perpendicular to CN, or even GK. And those could work. Now, is DH perpendicular to LM? So here's DH. Here's LM. Yeah, I think we could probably say so. I mean, the only thing is that they're not touching each other, so they're not on the same plane. So actually, let me take that back. I said I'd say so. I'd probably say no. Actually, I'm going to take that back. And that's probably because they're not touching, right? Which means they're not coplanar, but that's kind of a tricky one. I mean, if you were to extend those forever, again, touching, maybe, I don't know. But that's kind of a tricky one because they're not on the same plane. But yeah, let's not worry about that one. That one seems a little weird to me. Let's move on to this table here. This is very, very important. Super, super important. This will be the basis for chapter 3. We're going to refer to these terms a lot today and next Monday. Corresponding angles are angles that look like this. And the best way to think of that is that you have an angle formed between the red line and the blue line, and another angle formed between the red line and blue line. We call those corresponding angles because they have corresponding positions. And a transversal, just so you know, is a line that passes through two lines. Now, obviously, the two lines I'm looking at right here, let's say it calls like L and M, they're not parallel, but we are going to make these parallel eventually. And what you'll find is that angle 2 will equal angle 6 if L and M are parallel. We're going to be talking about that, I think, in the next set of notes, or maybe 3 notes. But for now, you just have two random lines, and you have a line that passes through both those lines. That's called a transversal. So T labeled for transverse. Trans meaning passing through when you're in transit, right? You're passing through. And those are corresponding angles. Now, alternate interior angles, they're both inside. Interior means inside. For those who play football, if you're an interior lineman, that means you're on the inside, right? Or if you're into decorating a house, like you have an interior decorator, they decorate the inside of your house, right? Or if you're painting your house, paint the interior, painting a room, like maybe a bedroom, a bathroom, or a living room, dining room. Or the interior of your car, right? You know, you're cleaning like the car seats, the floor of the car. So interior is inside, and they alternate. So they're basically like opposite sides. So you see 4 and 5 are opposite sides of the transversal, but they're both inside the two lines. Now, exterior would be the outside, right? Like, for example, if you're painting the exterior of your house, you're painting the outside, the exterior of your car, the outside of your car, right? So opposite sides again, because they alternate, but they're outside the two lines. And finally, we have consecutive interior. So interior, they're both, but they're inside again. But they're on the same side. That's why we say they're consecutive. So 3, 5. So very important, get these etched in your memory. 2, 6, those are corresponding. 4, 5, those are alternate interior. 1, 8, those are alternate exterior. 3, 5, consecutive interior. Now you have to name them, not that hard. There's a lot of different corresponding angles. Like you could say 1 and 5. You could say 2 and 6. You could say 3 and 7. Or you could say 4 and 8. See how 3 and 7, those are corresponding. Alternate interior, you say 2, 7, or 4, 5. So 2 and 7 are alternate, they change positions. See 4, 5, alternate, opposite positions, and they're both inside. Alternate exterior, you can say 1, 8, or say 1, 8, or 3, 6. Consecutive interior, or same side. I like to call them same side interior. But same thing. You can say 2, 5, or 4, 7. Those work. Okay, that completes this video.